Let's take a look at some properties of definite integrals. So the first one that we're interested in it is this. I'm going to write b up here and an a down here. So the lower limit of the integral is a, the upper limit is b. And I'll just put some general function, d of x. Now, if I were to take the negative of this thing and I was to switch the upper and the lower limit, they would be equal to the same thing. So that's kind of like the mirror image that we did before, except this time notice that we're switching the upper and the lower limit. And if we do it this way, then the two are equivalent. And we didn't have to create a new function g of x. So that's property 1. If I want to show it to you with numbers and an example, maybe I could write something like this. Suppose you're trying to find the area of this thing. Well, it would be equivalent to looking for the area of this thing. Those two are the same. So these two things down here are equivalent. If the one on the, they're both going to be positive. In this case, it's going to be two negatives on the right-hand side and just a positive value on the left-hand side. Property number 2. If I want to find the integral, well, I'll keep it in general terms, f of x dx between a and a. Well, the distance there is equal to 0, and the area is going to be equal to 0 as well. So not a surprise. A minus a is equal to 0. The distance is 0. There's nothing there. The integral between, say, 2 and 2 of x squared is just going to be equal to 0. So there's nothing of interest there. Property number 3 is going to look familiar. So we've got, remember, these are the properties of definite integrals. So if I've got b, I've got a here, and then I've got, I don't know, how about a f x dx, where a is a constant real number. It can be any number. Pick a number or any number. Then I can just rewrite this as a b a f of x dx. Right? And so multiplicative constants can be moved outside the integral. Or I could call it the integrand. Now, property number 4. If I have, say, a is less than c, and c is less than b, and I've got the integrand of some, or I've got the integral of some function, I could write this as a to c f of x dx plus c b f of x dx. And of course, a, b, and c are real numbers and constant. So if I had something like 4 to negative 4 f of x dx. I could rewrite this as -4 to 0 of x dx plus f of x dx. Here's a diagram illustrating property 4. Here we've got b is some value, positive value. It's larger than c. C is also a positive value, and it's larger than a, which is also a positive value. And so you could integrate the whole thing all at once, or you could break it into little pieces, and you could take that and add it to that, like so. Whatever's easiest, whatever you prefer. All right, let's evaluate this definite integral together. So the first step is to integrate the function f of x with respect to x. So I'll put a vertical line, 4 at the top and -4 at the bottom. And looking at this thing, well, you know, I could say, well, let u equal x minus 1. And then we've got u to the 3. And if I integrate that, I'm going to have u4 over 4. And replace the u with what it actually is. And there we go. We've integrated this function. And so I've got x minus 1 to the power of 4 all over 4. Now comes kind of the hard part, or at least the part with lots of calculation. Maybe not hard part, but it's more work. And so I'm going to start off by plugging in the upper limit, and I get 4 minus 1 to the power of 4 over 4 minus, now I'm going to plug in the lower limit. I've got -4 minus 1 to the power of 4. That looks like an awfully big number. Divided by 4. And if I do a little bit of simplifying here, I've got 3 to the power of 4 minus, well, -5 to the power of 4, and the whole thing divided by 4. So I am going to not try and do this in my head. I'm going to turn to my calculator. And my trusty calculator says that I've got, well, I could have done it in my head, but over 4, well, I probably would have got stuck right about here. And the value is -136. What? Didn't I tell you that it's not possible to have negative area? Well, what we've done here is we've just taken the integral. We didn't necessarily measure the area in the sense of we looked at it earlier.